dogs.
To understand why this is so frustrating for them, we have to look at the evolutionary divergence between pursuit predators and ambush predators.
Okay, pursuit versus ambush.
Right. Dogs, wolves, coyotes, they are pursuit predators. Their biology is engineered for endurance. Running down a target, the act of the chase itself, is deeply rewarding to their nervous system.
Because they just run and run until the prey gets tired.
Exactly.
Okay.
But cats are obligate ambush predators. They do not have the lung capacity or the fast-twitch muscle endurance for a prolonged chase.
So they are sprinters, not marathon runners.
Not even sprinters, really. They are calculated snipers. Their entire neurological wiring is built around a highly specific, low-energy, high-yield sequence.
Which is what?
Stalk, observe, calculate the precise physics of the strike, and then execute a single fatal pounce.
But look at what we do. We dangle a toy 3 feet in the air. We whip it around in unpredictable circles. We make it fly back and forth at match speed. We are essentially forcing a sniper to run an obstacle course.
And in doing so, we activate their predatory drive without allowing them to biologically resolve it.
Huh.
The mechanics of the feline dopamine cycle are fascinating here.
Okay, tell me about the dopamine.
In an ambush predator, dopamine, which is the chemical responsible for motivation and reward, doesn't peak during the observation. It peaks at the exact moment of tactile capture.
The moment of capture.
When their claws sink into the prey and their jaws clamp down, that is when the neurological reward is delivered.
So when we keep a toy constantly out of reach, trying to make them do backflips to entertain ourselves, we are hijacking their neurochemistry.
Completely hijacking it.
We are spiking their drive, but denying them the chemical release. It's like, okay, imagine setting a beautifully cooked meal in front of someone, letting them smell it, and then pulling the plate away the second they pick up a fork. Over and over again. You wouldn't be bored, you would be furious.
That is the exact mechanism that leads to play aggression. When a cat has a spiked prey drive and no resolution, that energy has to go somewhere.
Let me guess, to my ankles.
Yes. It often gets redirected to the owner's ankles as they walk away, or it turns into chronic anxiety. The notes emphasize that to fix this, the human has to undergo a massive ego death regarding play. You are not a jester trying to entertain a pet. You are a wildlife simulator executing a biological script.
A wildlife simulator. I love that framework. So how do we rewrite the script? How do we actually simulate this properly so they get that dopamine release?
You have to mimic the ethology of a small prey animal. Mice and birds do not fly aggressively at a cat's face.
Right, that would be a very brave mouse.
Exactly. They move erratically, but they also freeze. They hide. So you move the toy slowly along the baseboards, you pull it out of sight behind a pillow, and leave it there for 10 seconds.
You let them stare at the pillow.
You allow the cat to engage its visual system, which is highly tuned to detect minute movements in low light, to actually stalk the toy.
You let them do the math.
You let them do the math.
Yeah.
And then comes the critical resolution. You must allow them to catch it.
Oh, you actually have to let them win.
Yes. Not just tap it, but physically overpower it. You will often see them grab the toy with their front paws, bite down, and then rake it with their back legs.
The bunny kick. It looks so cute when they do that, but it's actually incredibly violent when you think about what it's meant for.
It is a disemboweling reflex.
Whoa.
Yeah, in the wild, the bite severs the spinal cord, and the raking of the back legs eviscerates the prey to ensure it cannot fight back and injure the cat. When you allow your cat to fully execute this motor pattern on a kicker toy or a stuffed mouse, you're giving them profound psychological relief.
They've successfully completed the survival sequence.
Exactly, the tension is released.
And the difference in their demeanor afterward is staggering. They don't just walk away frustrated, they groom themselves, which is a sign of a completed hunt, and they go to sleep. You've given them actual satisfaction. You've spoken their language of survival and proved that you understand how they are built.
It transforms the dynamic from frustration to partnership. You are facilitating their fundamental nature.
Okay, so we have bridged the gap with physical touch by targeting pheromone glands, and we've aligned our play with their ambush neurology. Now, the narrative of this deep dive takes us into an entirely different dimension of connection.
The invisible space.
Yes, we are moving away from the physical and the tactile and entering the invisible acoustic space we share with them. We are talking about the auditory environment and how we craft a vocal identity.
The auditory world of a cat is vastly more complex than ours. I mean, their ears are controlled by 32 separate muscles, allowing them to rotate 180 degrees independently like little satellite dishes.
Which is wild to watch.
It is, and they can hear frequencies up to 64,000 hertz, whereas human hearing tops at around 20,000.
64,000.
Yeah, they are living in a symphony of high-frequency data that we are completely deaf to.
Which explains why they can hear a moth landing on a window screen from 2 rooms away. But what does this mean for how we speak to them? Because we all talk to our cats, we pour our hearts out to them, and sometimes they seem to listen, but a lot of times they act like we aren't even making a sound.
The researchers at Paris-Nanterre University actually quantified this exact phenomenon in a brilliant study from 2022. They wanted to know if cats could truly distinguish their owner's voice from a stranger's.
Right.
And more importantly, what specific acoustic parameters triggered a response.
Okay, so how did they test this without the cat just reacting to the owner's physical presence?
They use a very clever habituation-dishabituation paradigm.
Habituation, what? Explain that for us.
Basically, they placed cats in a room and played a recording of a stranger calling the cat's name. They played it several times until the cat habituated, meaning the cat got bored, got used to it, and stopped reacting.
Oh, okay, makes sense.
Then they suddenly played a recording of the owner calling the cat's name.
And what happened?
The cats instantly dishabituated. Their ears swiveled, their pupils dilated, they oriented toward the speaker. They undeniably recognized the acoustic signature of their owner.
Fascinating.
But, and this is the massive caveat that changes everything, they only show this recognition when the owner spoke in a very specific register.
Let me guess. It wasn't the voice they used to order a coffee.
Exactly. When the researchers played recordings of the owner speaking in a standard conversational adult tone like they were talking to another human, the cats largely ignored it.
Really? Just ignored it.
It didn't cross the threshold of relevance. To a cat, your normal speaking voice is essentially environmental noise. It's the hum of the refrigerator. It lacks the acoustic markers of social intent.
It's just background radiation to them.
Pretty much. But when the owner shifted into a cat-directed, tone-short phrases, slightly higher pitch, softer volume, the cats locked in.
Because that specific modulation mimics the frequency range of positive feline communication.
Yes. Purring, trilling, the chirps a mother cat makes to her kittens, these all exist in a higher, softer acoustic space. When humans adapt their voices to match this, the cat's brain registers it as a direct, affiliative social signal.
But this is where I really need to push back.
Okay, go for it.
Because if they respond better to higher frequencies, human logic dictates that we should just go all the way, right? We break out the insanely loud, squeaky baby talk. Who's the best little fluffy kitty in the whole world?
Oh, please no.
Right. If high pitch is good, shouldn't extremely high pitch be better?
That is the exact trap of human escalation. We mistake intensity for clarity. Think back to their auditory anatomy hearing up to 64,000 hertz, designed to hear the rustle of a mouse under snow.
Oh, right.
When you blast them with high-volume, hyper-energetic baby talk, you aren't communicating affection. You're inflicting sensory overload.
It's an auditory assault.
It triggers the sympathetic nervous system.
Yeah.
The cat doesn't think, oh, they love me. The cat's brain registers a massive influx of chaotic, high-energy acoustic data, which in nature usually signifies a threat or extreme distress.
It causes anxiety.
It absolutely causes anxiety.
So we are caught between 2 extremes here. Our normal adult voice is ignored as background noise, and our intense baby talk is processed as a threat. How do we build an actual connection in that tiny middle ground?
You have to consciously curate a vocal identity.
A vocal identity.
This is a concept where you deliberately establish a specific, consistent acoustic baseline exclusively for your cat. It requires discipline. You drop the volume. You soften the timbre of your voice. You use brief, predictable phrases.
You essentially build a private frequency just for them.
Yes, an acoustic anchor. When you use that precise, gentle tone consistently over months and years, it becomes Pavlovian. It ceases to just be a sound and becomes a neurochemical trigger for safety.
That's beautiful.
If your cat is startled by a vacuum or thunder, that specific vocal identity acts as an auditory sanctuary. You're creating a space of absolute calm in an otherwise overwhelming sensory world.
It's not about performing for a cute reaction. It's about being a reliable, quiet presence. And that theme of quiet reliability perfectly bridges us to our next major